So in this problem, we have a stone being thrown horizontally at 12 meters per second from the top of a cliff that is 42 meters high. And if you're the kind of person that likes a sketch, here's a cliff, and your stone goes off that way, and you know it's going to go until it hits the ground. And this is 42 meters. So the first thing we should always do is write what we know. But because velocities and motion in the x and y directions are independent from each other, we have to list them separately. So let's list x information and y information. The only thing that would go in both categories is time. So the stone is thrown horizontally. That means all of this initial velocity is in the x direction. And because there's no acceleration in the x direction, this is also the final velocity. So it's every velocity. In the y direction, there is no initial velocity, but the acceleration is 9.8 meters per second squared. So we also need to decide which direction we're saying is positive. I'm going to say this direction is positive for the x, and I'm going to go ahead and say this direction is positive for the y, just because that's the direction we're going in and it's easier. You don't have to say the same thing. Whatever works for you is fine. So that gives me positive 9.8 meters per second squared. We also know that the initial displacement is 0 and the final displacement is 42 meters. Remember, you can always assume initial displacement is 0 unless you're told otherwise. So this first question, how far from the base of the cliff does the stone hit the ground? This is asking for this measurement right here. That's displacement in the x direction. So we know, and we want to know this. If we look at just our information in the x direction, we don't have enough information to solve for our final displacement because we don't have time. And while the third equation does let you solve for displacement without having time, it requires that there be an acceleration. Otherwise, you end up with just getting v squared equals v squared, which when there's no acceleration, of course it does, because it doesn't ever change. So we have to find time first. And what determines how long the object is in the air is how long it takes to fall. If there was no gravity, the stone would just go forever in the horizontal direction. So we want to know how long it takes for that stone to hit the ground with its horizontal motion. So we know x equals x naught plus v naught t plus 1/2 at squared. And we know that x is 42 meters, and x naught is 0, and v naught is 0, so v naught times t is 0, plus 1/2 times 9.8 meters per second squared times t squared. So we can drop the zeros, and then 1/2 times 9.8 is 4.9. So if we do 42 divided by 4.9, we get 8.57. And we end up with second squared, and that equals t squared. So when we take the square root of it, we get 2.9277. Let's look at significant figures. We have 2 and 2, so we're going to round this to 2.9 seconds. So we know that the stone's in the air for 2.9 seconds. Now we want to know how far does it travel in the x direction in those 2.9 seconds. So we're going to use the same equation. But now we're going to use information in the x direction. You have to make sure you don't switch stuff around. You have to make this list like this, x and y, and then not swap things back and forth. The only thing that can go in both types of equations is time. So you have to be very, very careful about that. That's why we made that list first. So we have 0 plus 12 meters per second times our 2.9 seconds. Seconds cancel out. And since acceleration is 0, that's 0. So how far from the base of the cliff? For rounding to two significant figures, it's 35 meters. When we try to determine how fast it's moving, that is going to be a vector problem, because it's going to have the same velocity in the x direction, this 12 meters per second. But it's going to have sped up in the y direction, and it's going to have two velocities at the end. So we're going to scroll down just a little bit so we have enough room to finish this problem. So we know our final velocity in the x direction is 12 meters per second, and we need to calculate our final velocity in the y direction so that we can sum these vectors. We can use the equation v equals v naught plus at. So we get v equals 0 plus 9.8 meters per second squared times 2.9 seconds. And we get that v equals 28 if we're rounding to significant figures. So now we know that our x velocity is 12 and our y velocity is 28. You could have drawn these the other way. It doesn't make a difference as long as you reference the direction correctly, if you're asked for direction. But in this case, you're not. It says how fast. It's not asking about direction. It's asking for just plain speed. So you're saved on that one here. So in order to find the final speed, you do 12 squared plus 28 squared equals c squared. And you get that the final speed is 30 meters per second.